Hey there, all right. Simplifying radicals part 2. You can see what we want to do today is look at mixed radicals and try and turn them back into entire radicals. Well, let's start with an example. Okay. Sometimes you think, oh, these are going to be real easy, but they're a little bit different. The easiest way to do these, I think, is to look at it and say, hey, where did this come from? Well, I had the square root of something, and I was timesing that by the other radical, which I know is a 5, and ultimately it was the square root of this number here that turned into that 3, right? That's where this 3 comes from. So I got to think, well, okay, what number would have been in here? And actually it's 3 squared, or 9. And now I can just put them together under one roof and just say, well then, isn't this the square root of 9 times 5? And you would be oh so correct. And say, oh, it's the square root of 45. Well, that's not too bad. But they can get a little more complicated. Let's do another one to show you that. Okay, so the next one, we're going to throw some x's and stuff at you. So what if you had, say, a 4x squared and, say, a y, and then followed by the cube root of 2y. All right, so now that's looking a little more miserable. So where did this all come from? Well, we're working with cube roots, so it must have meant, okay, I cube rooted something here and multiplied that then by the cube root of 2y. So what would be in here? Well, it would be, if we just put our little bundle in brackets and it's cubed, that bundle must have been the 4x squared y. That must have been our little bundle. Okay. So I don't want to bring it out. I'm trying to bring it all back together. So really what I got here is this. I've got, let's make it one big radical now. I've got a 4x squared y that's being cubed and then multiplied by the stuff that's under this cube root, 2y. Okay, so what are we talking about? Well, this stuff cubed, let's just work it out. 4 cubed, 4 times 4 times 4 is 64. So I actually have a 64 times 2. So numerically, this must have been a 128. Then I got x squared, which is cubed, so there's actually 6 of them, right? Inner and outer exponents multiplied together. So you got 6 of them here, and there's no x's over here, so that just stays x to the 6th. Then I got y, which is being cubed, so I have a y cubed, times that by this extra y over here, so that must mean there are 4 of them. So there's my answer. Alrighty, a little bit more miserable, but doable. Let's move on to the next one. Okay, so in this one here, we're going to try to put all this together here. We're going to have a 2x and then y to the 5th. And then we're going to look at a 4th root of, and what do we got in there? 3x squared and y cubed. So, boy, we got everything and the kitchen sink. So let's see what we can squeeze into this. So we're talking 4th roots here. And let's see if we can just put it all under one roof right off the bat. We know we're going to have a bunch of stuff here that must have been raised to the 4th times by all these extra guys that didn't quite make it. So these guys are the extra guys. Put them on the outside there. And in the brackets here, we're going to have all the stuff that's out in front. So 2x and y to the 5th. Okay, so let's see what we got going on down here. Now that we're all under one roof, let's see if we can just work this out without too much aggravation. 2 to the 4th is a 16. Then we have x to the 4th. And then we have y to the 5th to the 4th, so you multiply those two together. Times that by all these other guys here. And now it's pretty easy. We're going to blend them together And we're essentially done, except that there's a little extra in a moment. Now, 16 times 3 is 48. And then we have 4 x's and 2 more x's, so that's 5 x's. And y to the 20 and y cubed is y to the 23. Now, normally we'd go, hey, good enough, we're pretty happy. Oh, wait a minute, I miscounted my x's here. Hold on, this is supposed to be 4 and 2 x's. This is supposed to be 6 x's. Don't know why I wrote a 5 there. Anyway, it's really standing out now, but anyway, I guess we'll never forget that one. Okay, because it's a fourth root, because of this, okay, there are going to be some possible restrictions on x and y. Now, x here, let's see, we got x to the 6, which we always want to make sure stays positive. Well, that means anything goes for x. So x could be any real number. Okay? And that's because it's always going to turn positive when you raise it to the 6. So it's not really a restriction on x, it's just making sure people know anything goes with x. But y isn't quite so simple. We got to make sure y to the 23 always stays greater than or equal to 0. We can't let it turn negative because we're trying to take the fourth root then of a negative number. If y was to be a negative number and we raise it to the 23, it would still be negative, and so it would fail. So this basically boils down to y has to stay as a positive number. Otherwise, we're in trouble when we raise it to the 23, because we want to keep it positive. So this is kind of the important restriction here on y. X is okay, but y's got a bit of a restriction. All right. Well, I think that's probably good enough for this. This is about as miserable as these things tend to get. So if you survive that, you're probably going to survive anything. And we'll catch you later.